Thank you very much. Okay. Welcome everyone to the 2020 Engineering Project of the Year Awards finalist presentations. My name is Sharon Chen. I'm the Awards and Recognition Director, and today we're here now for the finalist presentations of the small project category. Just a few housekeeping items. If you're a finalist, please mute your mics and turn off your webcam during the others' presentations that are not yours. The recording is in process, but we plan to just keep the access for the recording within our committee and with the finalists. Please do not send any Zoom messages to to either everyone or judges during the presentation, because we will be using that platform to intercommunicate between the volunteer team. Before we start, we want to begin by acknowledging the Indigenous peoples of all the lands that we are on today. While we meet today on a virtual platform, I would like to take a moment to acknowledge the importance of the lands which we each call home. We do this to affirm our commitment and responsibility in improving relationships between nations and to improving our own understanding of local Indigenous peoples and their cultures. In York Region, we acknowledge the ancestral unceded territory of all the Haudenosaunee, Anishinaabe, Mississauga of the Credit First Nation, and Mississauga people that call this land home. Please join me in a moment of reflection to acknowledge the harms and the mistakes of the past, and to consider how we are and can each, in our own way, try to move forward in a spirit of reconciliation and collaboration. So the Project of the Year Award aims to Engineering Project of the Year aims to recognize the projects by licensed professional engineers and their contributions to the community. It raises awareness of the engineering profession, connects these companies to their local engineering communities and potential community partners. This year, we're very excited that to announce that for every category, including the small category, we'll be giving out first to third place. The virtual awards ceremony will be taking place on April 7th, 2021 from 5:30 until 7. So winners will be likely notified before then. Without further ado, I really want to introduce our judging panel. First, we have Annabelle Lee, who is the chair at the PEO York chapter and a K-12 IT specialist at IBM. Secondly, we have Helen Dung, the rapid transit sponsor at Metrolinx. We have Anna Murray, Proton Exchange Membrane Technology Product Platform Manager at Cummins Incorporated. We also have Marissa Sterling, who is the President of Professional Engineers Ontario, and also the Assistant Dean and Director of Diversity, Inclusion, and Professionalism at the University of Toronto's Faculty of Applied Science and Engineering. And our fifth and final judge is Manal Chowdhury. She is the Technical Manager of Grid Innovation at Electra's Green Energy and Technology Center. For the schedule, each finalist have a strict 10 minutes to present their own materials. And after this 10 minutes, up to 7 minutes will be allotted for questions and answers from the judges to the finalists. So other finalists, you should not be asking questions during that time. In case of technical difficulties, don't worry, just log in into the same Zoom link. Should you get disconnected during your presentation time, you have 5 minutes to really log back in and resume at the elapsed time that you have. So for example, if you were 5 minutes into your 10 minutes presentation and you got disconnected, you come back and you finish the rest of your 5 minutes of your 10. Judges have declared all of their potential conflicts of interest, but regardless of whether their scoring will be counted for each of these the projects or not, they will all be participating in the questioning. Finalists, again, are expected to stay for the full duration of their category presentations. So during the wrap-up, I will give an indication for everyone within this category, which is small, to leave the Zoom invites. If you have any questions for a session, please contact through private Zoom message VAH hand in this afternoon, which is here. VAH stands for volunteer applicant host. If you see anyone with a V in the beginning of their Zoom name, that means they're a volunteer. Don't worry if you get disconnected, we'll let you back in. If you don't know who to reach out to, please Zoom message VZ Reza. Please don't message me because I will be the presenter computer, which that I cannot see your messages. Today's efforts would not have been possible without the whole team from the 2020 Engineering Project of the Year Awards Committee, and that includes Mohammed Reza, Huzaifa, Hani, myself, Lisa, and Demi Lauren. And in addition to that, you must, a lot of you must have interacted with some of our other volunteer committee members who were key during our awards process, even though they are not here today. And that includes the people who are listed here. So a big thank you to them. So without further ado, I would like to begin with the first presentation of this small category. Again, make sure that you have your timing devices ready because we will be cutting you off strictly at 10 minutes, and so that way you can keep track of your time. And note that once you are done presenting, we will stop the sharing of the screen. So at the beginning of the Q&A period, we will be stopping the. Okay, our first company is our one presentation. So please, Karima, please request remote control. Okay. But don't, so I will approve it. Just make sure that you can navigate through your slides.
Yeah, it looks like I can. Okay.
Perfect. I will give you a verbal indication of when your 10 minutes has started. Okay. So please start your presentation after that. Okay. Sorry, let me just actually.
How's the volume? Can everybody hear me?
Yes.
Okay, perfect.
Okay. Can you click to make sure that it can scroll again? Okay, perfect. Okay, so if you go back to the previous one.
Yeah.
So you may start presenting starting now.
Okay. So hello, everyone. My name is Karima. I'm with Lonergan Engineering, a electrical consulting engineering firm. And I'm going to be describing to you our involvement in the 3-bed ICU renovation at Stevenson Memorial Hospital. So a quick agenda for today. I'll begin with a foreword, go into the description of the project, and then go through the 4 criteria: innovation, social sustainability, commercial viability, impact to the community, and then a conclusion. So arguably, I would say there's a universal law that governs all fields of engineering equally, and I think we can all relate to it. Colloquially, it's known as Murphy's Law, which states that if anything can go wrong, it will. As engineers, when we design, we always have to assume the worst case scenario will happen. The question really is, can we live with the worst case scenario? So Murphy's Law was top of mind when we were doing this project. So here's a description of it. Stevenson Memorial Hospital was originally built in 1928. It's a very old building. What we had to do was convert 3 existing obsolete patient rooms into a separate, totally enclosed intensive care unit, complete with 3 new ICU patient beds. It had to be designed and built to current healthcare standards. And what we use in the building services industry is CSA Z32, which is electrical safety and essential electrical systems in healthcare facilities. We had a budget of about $1 million. And the schedule was quite interesting. We had to tuck it neatly between the first and the second waves of the COVID-19 pandemic. Keeping Murphy's Law top of mind, technically speaking, what we had to accomplish was to meet CSA Z32, which outlines that critical care rooms are quite a bit different from basic care patient rooms in hospitals. Among other things, they require more electrical outlets, more circuits, more mechanical ventilation, more emergency power than basic care rooms. But there are different levels of priority of the emergency, the essential electrical system. In CSA Z32, it describes that the most important loads, if there ever is a power failure, the most important loads should be able to come back online via the generator and, the quickest. And the order of importance are vital loads are the most important, followed by delayed vital, followed by conditional loads are kind of a little bit more discretionary. In our facility, what we had to work with was there was but one branch of emergency power, and there was no electrical meter to indicate what the loading on our system ever was. So we realized that our biggest problem was we didn't know if we had enough capacity on our emergency generator. Because there was no meter anywhere in our system, we had to rely on our calculated load estimates that told us that with our new ICU loads, including all the mechanical equipment, there was a chance that if we lost normal power and switched the entire branch to the generator in one step, there was a chance that we would overload our generator, and that wasn't a scenario that we were willing to entertain. So we had to come up with a solution. Our solution was a load shedding panel board. So I'm going to show you a very, very simplified single line diagram of our distribution. On the left, this U represents utility power, and the G represents generator power, and the ATS is an automatic transfer switch. Ordinarily, if utility power fails, the generator will start up and feed the electrical system, and EPP1 is our emergency electrical panel. Our idea was to replace that panel with a new panel board, refeed all the existing emergency loads and their new vital loads from the new panel, but we would also install a meter on the panel board. The meter would be connected to the ATS and monitor the load on the generator. If the generator load started to reach its capacity, we would shed some of the less important loads from the panel. And we established that ventilation for the ICU was classified as conditional according to CSA Z32. So we were able to pose conditional loads on these load shedding breakers, effectively creating a conditional branch of power in the hospital that wasn't there before, and allowing us to be able to salvage some of the capacity of the generator. In terms of social sustainability, obviously in the short term, having this ICU open allowed us to have ICU capacity in time to support the second wave of the pandemic. The first patient was actually brought in on February 2nd. And in the longer term, the hospital never had the facilities to support high acuity patients before. And now we allowed it to, working with just what they had in their existing system. To be commercially viable, of course, we had to attempt to meet the budget as well as possible, and we had to meet the schedule. But of course, Murphy's Law reared its ugly head. Days before occupancy, it was discovered that that intelligent load shedding panel, EPP1, was going to be delayed by at least a month. And that was a scenario we would not accept. We had to get this thing open as soon as possible. So here's our single line. I'll explain to you what we were dealing with. Our plan was to replace EPP1 with a new panel. So we were going to remove the existing panel board and bring in a new panel board. It, in reality, consisted of two panels, one sub-fed from the existing. So panel 1A here was actually sub-fed from the existing EPP1. Now we were told that the main panel wasn't going to arrive for a month. However, that sub-panel EPP1A had been delivered and it was on site. And we didn't want to wait a month to get that first panel to be able to open our ICU. So the construction team came up with an idea. They said, why don't we keep the existing panel and feed the new EPP1A panel from that panel temporarily until we received the permanent panel. It seemed like a good idea. However, panel 1A was designed to be series rated with panel 1. What the heck does series rated mean? It means that in the case that we have the worst possible short circuit fault in our system, these two panels would only be able to safely interrupt that worst possible fault if they're working together. On its own, EPP1A was not rated to interrupt the worst possible short circuit that our system could encounter. So it wasn't safe. So we had to scratch our heads and figure out what else could we do in order to get this ICU operational. So what we came up with was installing an isolation transformer. An isolation transformer limits the maximum fault current that flows downstream of it. So with this isolation transformer, our system was considered safe in our eyes. It cost us an extra $5,000 and it took 4 days into our schedule, but it was still a better option than having to wait an entire month for that main panel to arrive. And then we had to disconnect the new AC unit to make sure that we didn't overload our generator at this, but which that was fine because we didn't need the AC unit in the wintertime. The impact to the community, there's not much I need to state. We were able to open the ICU unit on February 2nd. We admitted the first patient. So in conclusion, we can learn from Murphy's Law. As engineers, we're always considering the worst case scenario of situations. However, risking human life is never an acceptable scenario, but everything else is. Thank you.
Thank you, Karima. I would like to ask you to, there was a slight technical difficulty where the judges were exited out of the main room to a breakout room just for like 30 seconds. So
okay.
I'm going to give you a minute and a half to just represent the slide that they would have missed, which I believe it is this one. Judges, is that correct?
Yeah, it was That's the start right. of
the single line diagram, right? Okay. Okay, Karima, please go ahead starting now.
Okay, so Murphy's Law top of mind. Our solution to solving our generator capacity problem was a load shedding panel. So here is a very basic version of our single line diagram. On the left here, U represents utility power, G represents generator power. When utility power fails, the generator kicks in via the transfer switch, which feeds the our idea was to replace that existing panel board with a new panel board, refeed all the existing loads and the vital ICU, but then also install a meter on that panel, which would be connected and measure the load on the generator, such that if the generator reached close to its capacity, certain breakers in the panel would open and shed some load, allowing us to salvage some of the load on the generator. And what we discovered, or what we established, was that the ventilation for an ICU is classified as a conditional load. So we were able to put the ventilation units for our new ICU on those load shedding breakers, effectively creating a conditional branch of power and salvaging some of the load on the generator and allowing this actually, this made our project possible. If we hadn't been able to do this, it wouldn't have been possible to feed the new ICU.
Thank you so much.
Is there anything else that was missed?
Thank you so much. And I apologize for the technical difficulty.
Sure.
Now now the 7 minutes will begin for the judges to ask their questions, starting now.
Yeah, hi, it's Marie's sister.
Hi.
I'm muted, there we go. Yeah, I just wanted to ask you, this solution that you shared with us, how novel or unique is it in your industry, and how likely could it be applied to other situations?
Usually, well, I've been involved in hospital design since maybe the beginning of my career, and I've never done an intelligent load shedding panel before. The reason probably is because I've normally done new construction hospitals, and it's not the first solution that would be considered. The first solution would be to have separate transfer switches, separate panel boards, and everything sort of separated. This is sort of like a retrofit solution, the best we could do in the situation that we had. But it certainly could be applied to other existing facilities. To any time that you have a capacity issue, it's a good solution for sure to prioritize your loads.
Sure. And just a very quick follow-up question is, how much of an issue is it for us in this region or in the province, the country, around the need to convert patient rooms to ICU rooms? Is that, is that like an emerging issue? Has it kind of been a long-standing
I think
one?
so. I think so. Definitely at Stevenson Memorial, they've had it on their things to do for quite a while now. It never seemed possible until it always takes a little while to get things going, and to get the funding is always a difficult thing as well. So and then now, of course, with this pandemic, it's just all the more urgent to have intensive care available.
Thank you.
Sure.
Thank you for your presentation. This is Anna speaking. Was this solution for load shedding, is that only during the transfer that the concern is that these loads would maybe have peak, or is this would this actually be load shed while the generator was running? So that you would not have ventilation if you were reaching capacity on the generator.
Yeah, so the way it would work is the breakers would actually open, and then the transfer to the generator would happen. And if the generator had capacity, the breakers would close. So there would be a few seconds or moments when there wouldn't be ventilation in the ICU unit, but it's acceptable for a very short amount of time to not have ventilation. That's why they're considered conditional loads as opposed to vital loads. Vital loads, you can only have a maximum of 10 seconds where they're not running.
Yeah. Okay, so this was a solution during transfer. So as the generator is ramping up and before the transfer, or when the transfer switch kicked in, or?
Yeah, pretty much. And the idea too is that it's usually mechanical loads that have an inrush. So when you lose power and you initially have to transfer to a generator, the mechanical loads are usually what the concern is, because there's an inrush. After a few seconds, they kind of die down. So in a traditional hospital transfer scheme, we like to keep the mechanical loads on a separate transfer step loads, so that you can transfer the important loads over, get them going in 10 seconds, and then wait a little bit and then transfer your mechanical loads over, so you don't overload the generator with the inrush of the mechanical loads.
And it was easier to do this with a panel than, say, putting VFDs or something like that on the loads?
Yes, it was easier in this particular case because all the existing equipment. Oh, you mean for our new equipment? Yeah. Yes, it was easier. We actually had a VFD on one of the pieces of equipment, but there was still a risk that while the generator was running, that after the inrush, there still might be a capacity issue. So it kind of protected us in that way as well. Okay.
Yeah, I also thought the short-term solution of the isolation transformer to deal with the short circuit current was that was clever.
Yeah, that was a big bomb to drop on the construction team. I didn't want the ICU to be open, feeding it from that panel 1A. It was a very stressful time.
How did you manage to find the space to fit a transformer in?
It was beside the generator. It wasn't a very big transformer. It was a 30 kVA transformer. So we managed to find a corner. Yeah.
Still, dropping a transformer at the last minute is not so straightforward.
Absolutely. Credit to the electrical contractor for sourcing that transformer in 4 days too. Yeah.
Impressive.
Hi, Karima. I had a question actually.
Sure.
At the very beginning of the presentation, you mentioned the differences between the loads, the vital, the delayed vital, and then the conditional. Can you describe some of them just as examples?
Oh, sure. Yeah. For example, an electrical receptacle that would be in the medical service unit of the head wall of a patient room. In a critical care room, that would be a vital load. A delayed vital load would be ventilation in an operating room. Delayed vital loads are permitted to come on within 2 minutes. So if ventilation in an operating room went out, in 2 minutes, it needs to come back on. And conditional load would be something like cooling for an intensive care unit.
And what's the timeline for that? I would assume it's a lot longer, right?
It's a lot longer. Conditional loads are kind of more discretionary. It's up to the healthcare facility administrator to decide when those need to come on. The only thing that CSA Z32 dictates is that they do need to have a generator backups. They do need to be able to be backed up by some other source.
Fair enough. Thank you.
Sure.
Thank you, judges. That's all the time we have for questions. The judges will now go into their 3-minute breakout room for writing down their scores. Thank you to the presenter. Thank you, Karima. I would like to ask the next presenter, S2, to get ready for their presentation. Okay, for S2 SORSYS, could you please, one of you please request a remote control? Okay, so I'm approving the request now. Just make sure that you can flip through your slide deck properly.
Hello, can you hear me?
Yes.
Okay.
Do you, Samantha, do you have control, or is it Saeed?
I have a control.
Okay.
Looks like, yeah, I have it here. Yeah,
okay.
Good.
Great. So I will give you a verbal indication once the judges are back and you may begin your presentation, but there are still just hang tight for the time being.
Okay.
And I will let you know once your 10 minutes will begin.
All right.
So the judges will be back soon. They have around 20 seconds. So, okay. Zypha, is everyone back? Yes. Okay. Great. So all of our judges are back. That's great. So I am setting up your timer for 10 minutes. Your presentation will begin now.
Okay. Everybody, can you hear me now?
Yes.
Okay. Okay, good afternoon, everybody. My name is Salman Sahrai. I'm a mechanical engineer at SORSYS Technologies. Together with my colleague, Said Khosrawani, we are going to present the project Road Surface Mapping, a vehicle towed device for pothole detection. Just a brief introduction to SORSYS Technologies. SORSYS is a small size automation company in GTA. At SORSYS, we are a group of engineers, mostly graduated from University of Waterloo, specializing in industrial automation, manufacturing, and robotics. Our main focus in automation is to integrate cutting-edge image processing technique into routine automation practices where better vision can help reducing cost and complexity of the system. To give you a little bit of background of this project, as you may know, municipalities spend millions of dollars to maintain their and repair their roadways. Pothole-related damages have proven to be a continuously unsolved issue every year. In only 4 GTA districts, there are over 5,300 kilometers of road in different classes, including expressways and local roads. City of Toronto spends over $6,000 per kilometer every year for patching, surface repair, utility cut repair, and sweeping, aside from amortization of these roads. In average, 200,000 potholes are being filled every year by the City of Toronto, following leads from public reports, where this process, as you can see from the right graph right here, is not evenly distributed throughout the year, leaving the city task force overwhelmed during a short period of time. And still, despite this investment, road conditions are still a huge issue that cities and public have to deal with. Pavement condition of a road network is an important aspect of road maintenance. The need to quickly identify instances where pavement conditions being to degrade is of high importance of managers of road networks. If a management entity does not make timely repairs to pavement that is in the early stage of decline, the condition of the pavement will rapidly worsen, ultimately resulting in very costly repairs or requiring the total replacement of the affected road segments. Therefore, it is desirable to identify the damage early in the pavement life cycle rather than pay high maintenance or replacement costs later, which is one of the objectives of these projects. As side benefits of this project, we can add improvement in vehicle dynamic control, route planning of autonomous vehicles, data sharing with OEMs validating low cost on onboard detectors, and predict the location of potholes for planning. There are a few similar systems in market that are trying to measure the road roughness. We can categorize them in 3 categories: those using camera to identify any unwanted feature on the road surface, including potholes, which is highly sensitive to glare and ambient light, and still offering the 2-dimensional status of the road. There are also smartphone-based systems that read the roughness of the road using apps, which are just so sensitive to noises and driving slide, and also they're not accurate. and also laser imaging techniques, which are complex and costly enough that not being able to be deployed in a large scale. In this project, however, SORSYS implemented a hybrid solution where the system measures depths using customized displacement sensor while moving on the road surface and detecting vertical displacement based on the calibration and the range of allowable motion set into its system. These data are merged with the data collected from images taken by the vision system. A special attention the main focus of this project was to detecting, categorizing, and localizing potholes, designing a user interface for visualizing the potholes on the map, also design a modular system easily attached to any vehicle. And also, to me, is one of the coolest features of this project was to calculate the volume of required filling material in any given stretch, where we have the area data from the camera and depth data from the displacement sensor. Then we can easily estimate the volume of any pothole. This data can be very useful piece of information for cities budgeting and planning. Here is you can see the timeline of the project. We started in October 2019, and on July 2020, we started the processing our road test data, resulting results. And by October 2020, we were prepared for documentation and production. Now, I would like to ask Said to walk you through more details, technical aspect of the project. Said?
So I'll try to be very quick here. So when we started this project, we started thinking about how we are going to define an index for the roughness of the road. We did, as someone mentioned, the project was a collaboration with Sheridan College. So we did some study, and it turned out that there is a standard roughness index, which is defined in and well known in the industry. And basically, it looks into the displacement of the suspension travel, and then it's and like you do this calculation over a period of time or distance, and then it will be a moving window coming with you, and then you calculate this displacement over that window, and you come up with an index. Next, someone. But at the same time, because now like we're measuring the displacement travel between the sprawling mass and the unsprawling mass of the vehicle, the vehicle movement and driving itself, by the nature, we know that the vehicle dynamics is much slower than the road roughness, of course, depending on the speed of the vehicle as well. And we implemented this technique, which at the first we just get rid of all of the very high frequency noises, and then we use a low pass, and then we subtract everything. So we will have a nice mid-range band, which only includes the information for the road surface. Next. Six Sigma thinking to think about all of the confusion matrices. What is a true positive? What happens if there's actually a pothole and we don't detect it, and what if there's no pothole and we detect it? So we did it. Next slide, please. We did this analysis. We came up with all of these noise factors, the ranges that made sense for us. What is the normal range of the vehicle? What if the road has some curvature? What if how sensitive is the algorithms that you're developing in terms of with respect to the driving style? And then we listed all of the methods that we had and the algorithms. So we came up with this table here. Next slide, someone. Then we started to look into the accuracy of any of these methods, and draw all of these the effects of the noises, and use these algorithms to detect the actual pothole. So we know that there's a pothole, we ran the algorithms, and then we try to see how sensitive is the algorithm to the noise. Next slide. We did the same thing exactly for the false positive. So if there is no pothole, but the algorithm is detecting a pothole, as you can see that the black one here has a very narrow range. Next slide. This is the final result. So we fed all of the GPS data, the steering wheel angle, the IMU information, and the displacement travel, and also the weather information, and we came up with this IRI index. Next slide. Here's the final product. As you can see here, we came up with a neat way of like showing and presenting the information on the map. As you can see, for example, the green ones are the roads which are having less roughness. The red ones are the riskier part of the road, and the yellow one are in the mid range again. Next slide. The prototype is shown here, and if you go to the next slide, because I know that you're not doing great in time, here's a video on the first trial of the prototype that we did in Sheridan College, and we started to collecting the information. And that you can see that the vehicle that we made is actually towed by another vehicle, and we have some video here. And that will go to the next slide, which is the last one. Yeah, I guess.
Sorry, that's your time.
Yep.
I will now stop sharing. Judges, you can start asking questions starting now, please.
Thank you
Yeah,
for
excellent.
the presentation. This is Helen here. So as far as I know, that there are still a lot of municipalities still send their supervisors to the road and check the road conditions. So I wonder that how does this techniques was shared with the community, the municipalities, and how's the implementation?
Okay, I'll respond that one. So the goal, the ultimate goal for this project is to like have this data, that aperture be able to connect it to all these more frequently traveling vehicles in the city, where we can use them on the public transportation, like all these vehicles, and so in a daily basis throughout the city or to the cities, the city doesn't have to like do anything. It's just slice data, then they can plan accordingly this
Garbage vehicle bosses and whatnot.
Thank you.
Thank you.
Just to follow up to that question. Oh, sorry. Sorry.
Go ahead, Marisa.
Oh,
I think
sure.
I
Sorry.
have too many questions.
Okay. So can you just explain where you're at with communications with municipalities? So do you already know what data municipalities would need, and that's what you're designing to, or are you at the stage, or you're at a different stage? Just trying to understand.
No, at this stage we are in we're gonna make sure that the data we are collecting, that we can analyze them where the data are reliable to present. We are at the stage of to contact municipalities for like we need some permits to go in a wider range with different type of apertures or devices on the road. We're contacting these municipalities. We talk to City of Toronto. We just starting like contacting them to get us the permit, so then we can go in the wider range of the data collection. then we are not at the stage that we talk to municipality for the final product. But at this stage, we are confident that these data can be used, analyzed, and used in city planning.
Yeah, definitely. If any help is welcome here, if you can, anyone can connect us to the right person over there. That's part of.
Yeah, I think that just a little bit side note, I think it would be more the services department would be the right source that you should connect instead of planning. I'm sure that York region may be very interested and MTO very interested as well.
Yeah, that makes sense.
There you go.
Yeah,
yeah, if I may ask, a very interesting project, a lot of opportunity there. When you're doing your data validation, how are you confirming that? Are you actually going out to validate with your own two eyes that the data collected is accurate, or what's the actual validation process?
Yeah, that's again a great question. Unfortunately, in that area that we were collecting, there are companies who are providing those data, and you go and buy those data, and they have the roughness, the information, but we couldn't find anything around their office. So what we did, unfortunately or fortunately, was that we did the eye inspection, of course, and also we ran we ran the vehicle multiple times, like 10 times, and then to make sure that other noise factors are not really we can eliminate those disturbance and noise factors. But at the same time, for the bigger potholes, we did have the GPS locations, so we literally one by one go there and check the pothole. But it's not 100% validated, as you said, because we just didn't have the data.
And I guess as a next step, if you are going to put this onto a bunch of city vehicles, obviously they're not going to allow you to put a little trailer on behind every bus. So is there a repackaging exercise, or what's the next steps?
Yeah, of course. So the tow concept is just to the ease of, so we can easily tow it with any vehicle right now at this stage. But we're gonna design our immediate next step would be to design the device that can be easily mounted under any buses, like public transport buses. So that device needs like a little bit changes on chassis and access to something. It's nothing access from the perimeter of the vehicle itself. So that's the immediate next step, to design that device to be able to be connected to any kind of vehicle without any limitation.
It's really interesting that there's a lot of challenges over there, because like you have to take care of all of the bumps. You have to take care of all of the dusts and then everything that's coming under the vehicle, which is probably not clean. So the IP rating is also another thing that you need to think about. So we have these matrices and we considered everything, but we haven't really tried to prototype that yet.
So do you have way?
Sorry. Sorry, we don't have. Sorry, that is the end of the time for questions. Thank you so much for our judges and to our presenter.
Thank you.
We will have to need to move on to the next presenter. But thank you so much for your time.
Thank you.
Okay, may I please get the S3 project to get ready for the presentation? Mark, please please request remote control.
Shane, are we going to go for?
Oh, sorry. I'm so sorry. Yes, you're right. Yes. Now the judges, thank you, will go into a breakout room for 3 minutes for their writing down of their scores. And while we're doing that, we're getting our next presenter ready for the presentation. So if the breakout room could be open, that'd be great. And Mark, I will be approving your request right now, but please see that your controls work. It has been approved. It's looking like it works, which is great. Okay. So I will give you a heads up once the judges are back and we're ready to begin your presentation.
Sharon, can you hear me okay?
Yes.
Thank you.
I can hear you very clearly. Mark, you will be the presenter for Resilient, right? Or is it both you and Adam?
Sharon, it'll be me, but if Adam could be unmuted for the question portion, if there's any technical questions.
Okay.
He would like to contribute there.
Sounds good. Okay. Perfect. We just want to make sure that we have the right setup. We don't want to be spotlighting the observer while the presenter is presenting. So perfect. Thank you. We're just waiting off for the judges, but just hang on tight.
So everyone should be back. Let me just double check this.
Now they're all back because all the
Now they're all back.
Okay.
Yes.
Okay.
Perfect.
So Mark, I am starting up your timer starting now. Please go ahead.
Okay, thank you, Sharon. Welcome everyone, and thank you very much for having us present today. My name is Mark Bassenthwaite. I was the project manager on this assignment. Also on the presentation as an observer is Adam Nespolo, who was the project engineer for the project. So today we're going to be discussing the erosion control and infrastructure protection at German Mills Creek, which was completed in the fall of last year. So I'll get started by providing a quick overview of the project. In 2019, Resilient Consulting was retained by the City of Markham to complete the restoration design for 6 watercourse erosion sites across the city. One of those sites we're going to be discussing today. The project is located in Markham towards the south end of York region. It's in a residential area. It's adjacent to a existing closed landfill, and the project design included the design and implementation of a naturalized slope to protect that closed landfill. The project was designed in 2019 and constructed in 2020. Well, I'll talk a bit here about the actual site. So as you can see, it's an eroded slope. It's within German Mills Park, which is in the city of Markham. German Mills Park is a naturalized passive use park owned and operated by the city. And you've got German Mills Creek flowing north to south through the park. The park is about 65 acres in size. It's quite a large piece of naturalized area within the city. It was first used as a sand extraction area through the 1940s and 1960s. At that time, it was then converted into a landfill. It operated as a landfill until 1975 when it was closed and capped. Over the years, the park has developed a very active, involved group of users that have assisted with the naturalization of the site. They actually have a liaison committee called the German Mills Meadow and Natural Habitat Committee with the city. There's also a very active Facebook group where park users share all their photos of wildlife sightings and observations of the site. As it's a larger parcel of land connected to a valley corridor in the city, there is a lot of wildlife in the park, including mink, muskrats, deer, ducks, various birds of prey, and several species at risk, including eastern meadowlark and bank swallows. You can see here some 3D images of the eroded slope area, just to get an idea of the lay of the land and the severity of the erosion that was at the site. So we did have some particular challenges with this project. All watercourse erosion control projects are quite unique, but this one did have some particular challenges. The first one being the nature of the watercourse itself. German Mills Creek is generated from a highly urbanized watershed. It was developed over a wide range of years with varying amounts of stormwater controls. So the end result is a very high energy and flashy watercourse system. In addition, when the landfill was constructed and eventually capped, the watercourse was shifted to the east and disconnected from its floodplain. So it was really tightened in by all the work that was done on the site with the landfill activities. And as a result, over the years, the watercourse has been downcutting and expanding laterally. One of the worst erosion sites on the property was this 5-meter high slope that had an inclination of 1-to-1 or even steeper at some places. In recent years, as you can see in the photo, the erosion began to expose the waste materials that were in the landfill, exposing them to the creek and resulting in water quality impairment. In addition to the challenging physical aspects of the site with the watercourse and the steep slope, there was ecological challenges as well because, as I said before, the site is highly used by local wildlife, including species at risk. And along with that wildlife and the species at risk comes a lot of environmental approvals. So with so many challenges and moving parts on the project, we needed a multidisciplinary team to address the problem. Our team members included Resilient Consulting, who were the civil water resources engineers and project managers, geotechnical engineers, soil engineers out of Scarborough, fluvial geomorphologists, geomorphics, and then an ecological firm, North South Environmental, and of course our client, the City of Markham. To solve this project or this problem with so many different objectives and challenges, we really needed to undertake an iterative design process with numerous objectives. The first key objective was really to ensure the watercourse and slope stability to mitigate risks to the landfill, minimize environmental disturbance during construction, and then enhance the terrestrial and aquatic habitat at the site. Our final solution involved cutting back of the slope, which resulted in the removal of about 1,700 tons of contaminated material, which came out of the former landfill. At that time, a 1.2 meter deep trench was installed at the tow location to protect the watercourse, or protect the slope in case the watercourse downcutted. And then a 2.5 meter thick rock buttress was constructed. That was the key slope stability feature. And then for ecological enhancement, the rock buttress was vegetated, and that essentially involves filling all the voids with topsoil and then planting the topsoil with a variety of shrubs. Over 300 shrubs were installed on the slope. The design fully satisfied our objectives for the projects. We were able to reduce the excavation and export of the contaminated material. We achieved the required global slope stability factors based on the stone size and the vegetation utilized. The stone would withstand the watercourse velocities. We didn't increase floodplain extents across on the other side of the watercourse or upstream of the site. And it was designed so that it could be constructed in a safe manner while minimizing disturbance to local ecology. So it was really by combining all the geotechnical and water resources, and environmental and geomorphic principles that we were able to design the project and deliver a final product that was really nicely designed. In particular here, we were able to avoid an overly hardened solution and provide a green solution, which is typically seen as being better for the environment, better for the local wildlife, and more sustainable and adaptable in the future. The project ended up being delivered under budget, and all the challenges were overcome. So the design optimization process happened in early 2020. As with all the watercourse projects in the GTA, numerous agencies required permits and approvals, including Toronto Region Conservation Authority, the Ministry of Environment, Conservation and Parks for species at risk, the Federal Department of Fisheries and Oceans for a Fisheries Act review. And then after the approvals, the project was tendered in spring 2020 and awarded to R&M Construction. So our final product, you can see here in this photo, generally considered very successful. The plants will be greening up this spring, and the site will look in a couple of years like nothing ever happened here. Our final construction cost of the project was about $500,000, and it was completed successfully in October 2020. The final product, we've received several compliments from local residents as to the aesthetics of it. And also we had a lot of positive feedback from the residents on the environmental controls that were used during construction. So how is the project innovative and sustainable? It was restored with a meadow seed mix that enhanced habitat for species at risk. We reduced the amount of time we were in the water by bypassing and protecting the watercourse. We added turtle habitat for habitat enhancement and removed invasive species at the site. Benefits to York Region, provides a nice stable slope at the site, minimizes the impact of the landfill on the water quality, demonstrates that the city and region are being aware and active of their environmental risks, provides a safe walking route along the trail, and also increases habitat for turtles and species at risk, such as meadowlark. And eventually the project was delivered on time and on budget, providing lots of benefits to the city and York Region. Thank you. Oh, there's my timer.
Thank you very much, Mark, for your presentation. I will now turn the floor over to, sorry, let me just stop sharing the screen. If you can just, let's see. Okay, I will now turn the floor over to the judges for their questioning since 7 minutes starting now. Annabelle, since I was cutting you off last time, would you like to begin, or do you? Oh, you're on mute, Annabelle. Annabelle, you're on mute.
She's still
muted. Oh, no. I don't have a question yet.
Okay. Well, the 7 minutes begins now. Okay.
Mark, thank you very much for your presentation. It's Marisa. Congratulations on what I describe as like a beautiful, elegant solution. So it's lovely. I have a question for you. All the contaminated material, the 1,700 tons, where did it go?
It ended up going to landfill at an approved licensed landfill. So the landfill that was at the site was built, obviously a long time ago. It wasn't a lined landfill. There's leachate and methane issues at that landfill. So it's ultimately better environmentally for that to go to a properly engineered facility now.
And is that, I'm just curious, are there other options or not for what could have been done? So I see that a lot of environmental considerations were taken in this project, and I'm just curious about that one.
Yeah, we actually did two distinct rounds of soil sampling that soil engineers completed for us, and we found that based on the level of contaminants in the soil, that it couldn't be reused at any other site. So it just didn't meet the guidelines. We also examined the feasibility of burying it somewhere else on site, but we discussed that with the city's landfill operations group, and they didn't like the idea of just simply moving the problem around the site and potentially making it worse in another location.
Yeah, great. Thank you.
Well, this is Anna. Thank you for your presentation. When you said you avoided coming up with a hard solution, do you mean like poured concrete at that point, as opposed to the layered rock solution?
Yeah, or even concrete is really not implementable on a watercourse project anymore from an approvals point of view. But by hard solution, I would mean something like a large armor stone wall. You see a lot of those where the water velocities are so high and the steepness of the slope requires a vertical wall. You end up with these massive armor stone walls, which are not, it's a natural material, but it's not a natural thing for a big chunk of rock to be there.
Mm-hmm. Hi, Mark. This is Helen here. So from what you presented, this project involved in multiple disciplines. So in your perspective, what are the key unique engineering solutions compared to other similar projects?
This one was unique because of the nature of the landfill that was immediately adjacent to the slope. That normally if that landfill wasn't there, the solution would be to cut back that slope at a more natural angle of 2-to-1 or 3-to-1, but that just wasn't possible here because we would have had to remove all of that material, which was a huge cost. So the engineering was really the optimization of the design to meet the geotechnical requirements for slope stability, the engineering requirements of not impacting the floodplain extents upstream or across the watercourse, and then making sure that the actual watercourse would remain stable as well, and balancing all of that with the ecology.
Thank you.
I'm going to jump in with another question. Is that okay? Yeah. So Mark, you mentioned that the community, the neighbors came out and they were giving some praise for the look of the solution. And I was just curious, how would you answer the question around how this project enhances the image of professional engineering?
Well, I would think that a lot of people don't associate a naturalized solution with engineering. So you think about engineers as, building concrete structures or highways and, very hard assets. In this case, it was a lot lighter touch. We had to come up with a solution that wasn't just hitting it with a sledgehammer. It was a little lighter. So I think that that can enhance our reputation as just thinking a little bit more than the easy solution.
We have time for one more question, 2 minutes left.
Everyone's questioned out.
Maybe I can ask the last question. So how does this lesson learned apply to other future projects or any ongoing projects?
Well, they're all pretty unique with water courses because you always have very unique constraints and criteria that you're looking for each site. I think for this one, what was nice was the integration of the multidisciplinary team to streamline the approvals, to have a design that didn't impact the natural environment too much during construction, and also achieved all the objectives. I think that was it. Build the multidisciplinary team, and listen to everyone involved, even if they're not engineers, right? Like it takes ecologists, fluvial geomorphologists, sometimes landscape architects are involved in these projects too.
Thank you, Mark.
Thank you very much, Mark, and thank you for the judges. The judges will now go to a 3-minute breakout room to record down their answers. Thank you, Mark, for your presentation. May I please have the next project, which is S4 CADMech. Please get ready for your presentation. Sebastian, would you please request remote control through view options at the top there? Perfect. Please click and flip through the different slides to make sure that you can navigate through the slides.
Oh, okay. Let's just scroll. All right.
Perfect. Okay, so our judges are still in their room, but I will give you indication once they're back and when you may begin your 10 minutes. Please make sure you have your timing device ready. Yep. Just be aware that if you're pressing arrow keys, it's actually on my computer or volume up. So
yeah, okay. So just scroll wheel then, right? Scroll
wheel or keys would be fine, but if you want to increase or decrease your volume, note that it's actually since you have remote control, it won't be affecting your computer, it'll be affecting mine. So just be aware.
Okay. Yeah, no.
Sebastian, are you the only presenter or are you, well,
Yes, I'm the only presenter. The
Okay.
other two that came in, I believe, are observers.
okay,
The other one that came in.
thank you.
Hey, Sharon, the judges are done. I just want to make sure they're all here. Yeah, okay, yeah, they're all here.
I see that they're all there because the room is all closed.
Good,
Okay,
good.
so Sebastian, I'm setting up my timer right now. So
All
I will
right.
count 3, 2, 1, go. I will start your timer for 10 minutes starting when I say go. So you may
Okay.
begin in 3, 2, 1, go.
All right. Well, I'm Sebastian Jurevich, a VR AR developer at CADMech Design. At CADMech, we're proud to be a part of the engineering community for, I think, the best part of 25 years, almost 26 now. And in 2018, we took up virtual reality development for education, training, and rehabilitation. Some of our work includes proof of concepts to improve engineering design review, as well as industrial training applications, geriatric center applications, and many more. I think we have a few in the works now, but there are many more on the way, and looking forward to those next year. What has really enabled us to do this is the upfront cost of headsets have like dramatically increased. Only a few years ago, they were $500. Now they're down to $400 for pretty much the same headset and actually better tech inside of it. At the beginning of 2020, oh, there we go. One of our clients, 40med, actually approached us with an opportunity to develop a full turnkey medical training solution to highlight educational purposes and possibilities of VR in the medical field. 40med is like a medical software device developer who intends to make healthcare simulations more accessible globally. So as I said, we started at the beginning of 2020. The first portion was actually a venipuncture training, which is really just drawing blood samples from a patient. The next portion was COVID testing, so the PCR test, the one that everybody gets, the nose swab test. So we go through all these procedural events, right? And I'll just show. See, okay, there we go. So this was so as you can see, there's actually one portion. So the way that it starts off is you're placed into an office, and a really nice one at that. Wish I had more video content for you guys. So you start in this office and you have your computer in front of you, and on the computer has all these procedures. And currently we have 3 procedures. One of them is still in a demo phase, and that's the surgical one. But currently we have 2 procedures fully working, and they are the venipuncture and the COVID testing. When you start, for instance, the COVID procedure, you load in to that scenario. You have to go through all the safety requirements, washing your hands, placing a mask on, placing the visor on because it's COVID, and then you go in, see your patient, tilt their head back, and then put the cotton swab into their nose, right? So the deliverables and the challenges that we really had to face, and I'll kind of go over this. The challenges that we had to face was we had to change the way that we thought about things, especially education, right? We have to understand how we learn, which seems pretty straightforward. We all seem to know, okay, if you repeat doing something, if you keep doing it over and over, well, you're eventually going to learn it, right? And that's very true. So repetition is extremely important because our bodies always take in sensory data, and then we encode it, and then it's eventually from short-term memory goes to long-term memory. And then whenever we repeat the task, we end up retrieving that data, and then we sort of know exactly what to expect and what we expect we need to do next. right? There's always special cases, but let's say we have some procedure. We know that we have to go through this procedure, and practicing that procedure is extremely important. So there's this the rule that for if you do something for roughly 10,000 hours, then you're going to become good at it. Now that's always up for the debate, right? Really, what it is if you repeat something over and over again, you're eventually going to know what you have to do next, right? And this will really reduce the number of mistakes that our nurses, doctors, and everybody make in the field and in labs, right? So when we do these experiences, we need to make sure that we either allow them to make mistakes, or we make them aware of the mistakes that they could potentially make while they're in the field, right? So because there's always a risk to patients, and we know that. My bad. Let me just see. Give me 1 second. So we know that we need to prevent that. The other key driver to learning is players' motivation. So the user has to really enjoy the experience, and we need to make it engaging. Now, stories is one way to make it engaging, and we try to do that to the best of our ability. The downside is the project scale that we had for this, which was only I think $50,000, so about 500 hours. We couldn't actually get a full story in there. However, we have this platform that allows us to immerse a player in a sensory experience where they are able to use hand tracking, controllers, gloves, and other peripherals to enhance the experience. So once we've done all of that, well, we know that hand tracking is extremely important, and it's something that we've done before. And it has a very flat learning curve. So anybody can get into it, and they'll know exactly what they're going to be doing. The problem is computational power, especially on headsets like the one that I have here, which is a standalone headset that you can actually run on your own without it being tethered. It uses a mobile chip, a mobile processor to do all of the work. And we didn't realize at first how limiting this processor was. So when we were doing this work, we couldn't have very high quality visuals that we could get, let's say, on a full size, like on a desktop when you have it tethered in. So what we had to really do was, although we wanted hand tracking, there was a major trade-off, right? We wanted it to look good, so we had to go to controllers. And the problem with controllers is that there's no real learning curve. And when we were doing this work, there was not really a standard for exactly how you were going to use the controllers, what the button layout was. So we had to do a lot of just testing, a lot of trial and error to figure out what button layout we wanted. And we didn't have certain games that it came out over quarantine, really. We didn't have games that came out until I think March, when Half-Life Alyx came out, and it did a phenomenal job of using controllers and applying those standards. So really our trade-off was, okay, there's going to be a bit of a learning curve, but we have to do the best we can. So we spent hours and hours working on that. The next thing that we had to do was we had to deal with collisions, right? And teleportation, all these locomotion systems are generally a problem because you want to be able to walk up to objects and not be thrown away. So you have to deal with a lot of velocity issues, right? If you teleport or run into an object, you can be shot backwards. So we dealt with a lot of that, and that was really just working out exactly how much physics is going to be applied to the player, and then limiting that. We also noticed that you could clip through walls, so we had to deal with that. How were we going to do that? And there was no clear set way. So now when you're going through walls, it ends up going black on your screen, so it fades to black so that you know, oh, I can't go there right now. Sorry. So I didn't actually highlight this, and I don't think I'll get a chance to, but this is a really cool study about hand tracking. So the honest impact on York Region is that it's going to revolutionize medical training, allow the reduction of costs for labs for universities and college students, and providing students with a visual and like sensory experience from the comfort of their own home, where they can practice over and over and over again until they ingrain exactly what they need to do next. So they don't have to refer to lab notes while they're in lab, or, you know, always rely on somebody else while they're out in the field. I think that's it.
Thank you very much to our presenter, Sebastian. I will now stop sharing my screen and stopping the remote control, stop share. And I will now open the floor up to the judges for questions for 7 minutes. Please go ahead.
Sebastian, thank you very much for your presentation. It's nice to hear. Help me understand a bit more about where you are in this project development. Is this something that you already have in the hands of some students? Is it like to be training, or are you in progress of that? Or
so at the moment, it's in the hands of our client, of course, and they're using it right now to go to universities and colleges and present it to them as, I guess, a proof of concept, so that the universities and colleges can buy in. And then we're going to continue development on additional features, right? So I was going to talk about potential surgical training. We are actually looking to do knee and hip replacement in virtual reality.
That's great. Thank you. And can you just give us a bit of a landscape of what else might be out there today to do this in terms of training for things like COVID tests, but also what you just said about the knee and hip surgeries?
How many are available? Is that what you're asking, or?
Yeah, is there a bit of this type of training procedures available today? And if so, in what kind of scope?
Okay. Yeah, there is actually. There's a few companies doing it a lot. I think a few in France. Actually, one major one in France is actually doing that. Their material is really stunning. I'm pretty sure they have a very large team. I know they have a very large team. But yeah, there's only one other company that I know of off the top of my head.
Thank you.
With your technology, did you have a chance, did you have people use it, and what kind of feedback did you get from people outside of your team?
Outside of our team, we had some people in Hong Kong that were using it for some time, just like, yeah, just as presentation material out in Hong Kong. And then there were a few other things that we had it on a, our client had brought it out to a VR AR convention and had it on display. We haven't got any responses from that, but they enjoyed it, thoroughly enjoyed it. So.
Have you had any actual doctors or nurses or students use it and give feedback?
We've had some doctors, although they were not in that specific field. And then I've had some students, because I've got a lot of friends that are in nursing programs testing it as well. Just a few, but you know, friends sometimes don't tell you the truth, so they always want the best for you.
Do you have any data to share that what will be the cost sharing if we utilize this technique and versus the traditional training?
No, I don't at the moment. That's I mean, I could definitely search it and bring something up, but I'd be lying if I told you I knew the exact statistics.
That's okay. Thank you.
Just to build on that question, you know, when you think about the societal value adds of this approach versus the current approach of training, what else would you suggest be considered, or are some of the value adds of training in this virtual reality approach?
So at the moment, I think that training in virtual reality should be something that you add on top of it, especially for medical training, because you definitely need practice out in the field and using the devices that they have at universities to do venipuncture training and all these other things is extremely useful. But when a student is on their own at home, they don't have those tools with them, and the expense of those tools is it's a lot to get one of those fake arms, for instance, made for each individual student at home versus getting a headset, right? So it allows them to study and have that aid there. Yeah, any other questions?
There's time for one more question.
Yeah, I have a question. So what were some of the lessons you've learned as you developed this particular product for 4D Med?
What I've learned, and there's actually a lot, there's quite a bit, but what I've learned is sometimes you do need to wait a little bit before jumping into a specific SDK, because you don't know how long that SDK is going to be updated and who's going to develop something a little bit better that you can use. Like the limitation that we had with grabbing objects is that it wasn't necessarily real. Like you want to be able to grab objects with two hands, right? You could do that with hand tracking, but with the controller, it was extremely difficult, right? Because you have to calculate all the physics and everything involved with having two hands. And if you go like this, well, the bar, let's say you're grabbing a bar, the bar should still sit there and your hands should still continue to be on it. So I think waiting for those things to come out would have been, I don't know. Playing the waiting game is also not a good idea. So I don't know. It was a very stressful time. I don't know how to answer the question.
How much research did you do about various SDKs and platforms? I assume by SDK you mean software development kit?
Yeah. So there were, what happened midway through development was a software development kit was released unbeknownst to everybody, or unbeknownst to a lot of people except for people that were in on the demo. So we had to change everything. We had to change our entire approach once that SDK came out, especially when we realized that it supported more than one platform, because we were only developing for the Oculus Quest. And then once that SDK came out, we were able to develop for HTC Vive, for the Oculus Quest, for all these other devices, like Microsoft devices as well. So really what has accelerated that is the pandemic, right? Everything started coming out because of the pandemic. And then once one of the games that I actually mentioned, Half-Life, came out, then that really brought a standard in on how interactions should operate and how much physics we should allow the player to actually have and how much control they have.
Thank you, Sebastian, and thank you, judges. That's all for questions. Reza, please. Now, the judges will now go into their own separate breakout room for their scoring writing, as well as the end of category deliberations. So meanwhile, the judges are being moved there. I will do a closing for everyone here. Okay. So thank you, everyone. Thank you all finalists for your time in coming into today's finalist presentations, and of course in applying for our awards this year. We really appreciate you taking time out of your weekend and out of your time in general during work to apply for our awards. Again, you are now able to exit the Zoom conversation so that we can get everything else ready for the next category. Again, the award ceremony will be April 7th, 2021. So winners will be notified before then. And regardless of the result, we would like to encourage everyone to apply for our awards again next year. Thanks again and have a wonderful day.